Okay, everyone, welcome to a video on composition of functions and inverses of functions. To start with, let's review a little bit about function composition. Remember that when you're looking at a function written in function notation, the f is the name of this function, so this is called function f. The input location is where x is, so this function takes 3, multiplies it by whatever the input is, and then adds 6 to it. So my first example is find f of 3. Find the function where 3 is the input. So that would look like this. The input location is multiplying the 3, and then we add the 6. So we're really just substituting 3 where x was. Now we simplify. 3 times 3 is 9, and 9 plus 6 is 15. So f of 3 is 15. We're using the same function again in number 1, but this time our input value is x plus 1. So we just replace where x is with the input value of x plus 1. So this is still 3 times the input value plus 6. Well, to simplify this function, we have to distribute first, which is 3x plus 3 plus 6. And then we combine like terms. So 3x plus 9. Finally, we're still using the f of x function, 3x plus 6, but our input is 1/3 x minus 2. So we start with 3 times the input plus 6. Again, we need to distribute. So 3 times 1/3 x is just x. 3 times negative 2 is negative 6. And then we have a plus 6 here. Well, that negative 6 and positive 6 cancel each other out. So our final output is just x. I'm going to go on over here to number 2 and keep working. Now our function called f is 2 times the input minus 4. So I'm going to input a 3. That means I put 3 where the x goes. 2 times 3 is 6. And then we subtract 4. 6 minus 4 is 2. So the input value is 3, and the output is 2. Let's plug in a second input value. 3x plus 5 now goes in the input location. So 2 times 3x plus 5, and then minus 4. I distribute, so 3x times 2 is 6x. 2 times 5 is 10. And then we have a minus 4. So we're just going to combine like terms here. 10 minus 4 is what gets to be combined. So we'll have 6x plus 6. Finally, I'm going to take my f function and plug in 1/2 x plus 2 where the x is. So this will be 2 times 1/2 x plus 2 minus 4. So again, we distribute. 2 times 1/2 x is just x. 2 times 2 is positive 4. And then we have this minus 4 on the end. And we combine like terms. So the plus 4 and minus 4 cancel each other out, and we have an output value of x. I'm going to keep going with example 3 and 4. If you want to fast forward to the new topics of the day, feel free to. In example 3, our function changes to x cubed plus 1. That means our input value of 3 is going to be cubed, and then we'll add 1. Well, remember, this is not 3 times 3 to make 9. It's 3 times 3 times 3. So 27 plus 1. Combine like terms, and our output is 28. Don't get scared by this input value. You know what to do with radicals. If we are inputting a cube root of x plus 1, but then cubing it, then we're working on an inverse here. A cube root and a cube will cancel each other out, so we'll just have x plus 1 plus 1. So we can combine like terms to make x plus 2. Same thing here. don't get freaked out by a cube root function. When you input a cube root and then cube it, that's our input value being cubed. The cube root and the cube are inverses, so they cancel each other out. So we'll just have x minus 1 plus 1. And then we can combine like terms, and the minus 1 and plus 1 cancel each other out for an output of just x. One more example to work on with you. Here we have the cube root of x plus 4 as the function. First, we're going to input a value of 4. So the cube root of 4 plus 4. Well, work inside your radical first for simplifying. That would be the cube root of 8. And you're trying to think what times itself 3 times equals 8, which is an output value of 2. Okay, next input value is 23. Input 23, where the x goes, add 4. Work on the inside of the radical first. 23 and 4 combine to make 27. And now you're thinking, what times itself 3 times makes 27? Or what's the cube root of 27? It's 3. 3 times 3 times 3 is 27. One final input here. We're taking the cube root of the input value of x cubed minus 4. Then I got to extend that bar because I also have to fit a plus 4 within the radical bar. So if I'm simplifying what's under the radical first, this minus 4 and plus 4 will cancel each other out. So I will have the cube root of x cubed. And then we talked about how a cube and a cube root are inverses of each other, so they'll cancel each other out for a final value of x. Okay, I hope you are seeing a pattern in our third input for each of these review problems. For each problem, we get a final output of just x, and that was not a coincidence. That is a well-designed review to lead us to our next topic about inverses. So when you're ready, come back to video number 2, and we'll start talking about the inverse of a function.